Okay, students. Now let us take question number 29. What it says is, identify the set of paramagnetic ions among the following. It means that he has gone 4 sets. We should find out in which set all the ions are paramagnetic. Okay, let us go by one simple technique. Let us identify one ion which is diamagnetic in nature from each set. We'll come to know the question answer very quickly. Look at this. If you concentrate on Zn plus 2, that is first set, what we notice is here it is D10 configuration. Well, before that, paramagnetic ions are those ions which have got either, not either, which have got partly filled d orbitals. Diamagnetic ions are those which have got either completely filled d orbitals or empty d orbitals. Well, this is completely filled d orbitals. Therefore, it is diamagnetic in nature. That means this set does not have all the ions which are paramagnetic in nature. Now let us look at another setting. Now look at this scandium. Its atomic number is 21. Its electronic configuration is 4s2 3d1. It means that it is in +3 oxidation state. It means that it has lost all the 3 electrons. It means it is D0 configuration. It is D0. It has got a D0 configuration. It means there are no electrons. That means it is also diamagnetic in nature. That means this set also does not have all the ions which are paramagnetic in nature. Now let us look at this one. Its atomic number is 22 and its electron configuration is 4s2 3d2. Okay. Its oxidation state suggests that all the electrons present in the outermost shell are completely lost. That means it is also a D0 state ion. D0. That means no electrons are present in the outermost shell. That means it is diamagnetic in nature. That means even this set does not have all the ions which are paramagnetic in nature. That means when these 3 cannot be the answer, this must be the answer. Okay. In fact, it has got 1 unpaired electron, this has got 1 unpaired electrons, and this has got 4 unpaired electrons. That means this set has all the ions which are paramagnetic in nature. Clear, students? Okay. Now let us look at next question, question number 30. It says, how many moles of acidified potassium dichromate is required required to liberate 6 moles of iodine from the aqueous solution of iodide ion. Okay. To calculate this, we need to write this equation which indicates meaning of acidified potassium dichromate. Let us look at this. K2Cr2O7 plus H2SO4. This gives K2SO4 plus Cr2SO4 thrice plus H2O plus 1 nascent O. Now to balance this, upon balancing this, what we get is Cr2K, 2K, Cr2, SO4, 3 and 4. 4H2SO4, it means 4H2O. Cr 16 plus 7, 23 O's. Here 12 plus 4, 16 plus 4, 20, 23 O. Okay. Now to make this equation simple, we write potassium salt, potassium iodide. Clear, students? Okay, because when you put this into water, we will get K plus and iodide ion, which are aqueous. Okay. Then what we do is we write Ki aqueous. When it is made to react with H2SO4 in the presence of this O, we'll get K2SO4 plus H2O plus I. Now check whether it is balanced. See here. 2K, yes, 2K, it's balanced. I2, yes, I2 balanced. H2, H2 balanced. S balanced. O, 5. 4 plus 1, 5. Well, this equation is balanced. It means that this equation has utilized only 1 O, but in the first equation we notice 3 O's are released. That means this has to be multiplied by 3. That means to write this resultant equation, we will have to add these 2 equations. 3 O's and 3 O's get cancelled. Then what we notice? Here, K2Cr2O7 plus 3 plus 4. 7H2SO4 plus 3 into 2. 6Ki. This gives 3 plus 1. 4 K2SO4 plus Cr2SO4 thrice plus 3 plus 4. 7H2O plus 3I2. Now look at this. It means that this implies that 1 mole of acidified potassium dichromate K2Cr2O7 is releasing 3 moles of I2. That means to get 6 moles of I2, we need 2 mole of K2Cr2O7. Therefore, answer is D. Clear, students? Okay, let's take up the next question.